So hello everyone, here is the new Leetcode problem of the day, which name is shortest path visiting all nodes. Leetcode 847 problem. So in this problem, we have given an undirected graph of 0 to n minus 1 labeling, and graph of I is a list of all nodes connected with the node of I by an edge. So we have to return the shortest path that visits every node. We can use the node multiple times, and you may reuse the edges. Let's see the example. So in this example, the shortest path will be 1 to 0, then 0 to 2, then again 2 to 0, because it is a undirected graph. So we can go, and we can see here we can use the nodes multiple times. So 0 to 2, then 2 to 0, then 0 to 3. So this will be our answer. And this example also 0 to 1, then 1 to 4, then 4 to 2, then 2 to 3. This is also simple answer. So let's see the intuition for this problem. So what will be the intuition? We can see this is a graph and we are traversing all the nodes. So we can use BFS or DFS, breadth first search and depth first search. So I will use BFS, and in this BFS I will take a queue and set and visited array. But visited array, except the visited array, I will use bit masking, because that will be much optimal for this solution. So let's see the intuition part. So this is the intuition strategy to tackle the problem. I will use bit first search, BFS, and this is the uh, definition of BFS. What is BFS? And you can see this. Breadth search is a graph traversal algorithm that explores nodes level by level, moving through neighbors before going deeper. In this specific problem, we employ VFS not just to explore the graph, but also to search through the different states that the graph can be each, and encapsulates the visited nodes. And you can see this, and you can see the BFS how it works and other all. You can the bit masking approach. Here is the bit masking approach. If we have visited the node 2, then we can write this as 2 to the power 2 equals to 4, and the binary form of 4 is 100. So it means we have completed the position 2. We have visited the position 2. It will be 0 1 2. Second position will be 1 and other position will be 0. It is a binary form of 4. And if we have visited the node 3, then 2 to the power 3 equals to 8. Then third position will be 1. It means we have visited the third position. So now we will use an OR operator. So if binary form of 100 and 1000, that will give me a 1100. It means we have visited the second and third index of the this graph. So you can see this also. Now we will go on coding part. So let's zoom this. So firstly, if graph dot size equals to 1, it means we have to return 0, because there is only one node. So the distance will be 0. So now return solve function. In this solve function I will pass graph only. Now I will add solve function. In solve, in the solve function I will pass the graph. Then let's copy this and paste this here. Then int n equals to graph dot size. This is done. Then I will make int all equals to 1 left shift of n minus 1. It means one left set of n, it means 2 to the power n. If n equals to 3, then 2 to the power n equals to 8. Then binary form of 2 to the power 3, 8 equals to 1000, and we are subtracting minus 1. It is not a integer part, so if 8 minus 7, if 8 minus 1 will be 7, so the binary form equals to 111. So that will be our answer. So in we can see all nodes are visited here, so that's why I am using one left shift of n minus 1. Then I will initialize the queue of pair of int comma pair of int comma int queue. It means first integer is showing the node, and second integer is showing the distance, and the third integer is showing the bit mask, our bit mask. Okay, then I will initialize the set of pair of int comma int type p. In this set, first integer is showing the index and second integer is showing the mask. Done. Then I will traverse for int I equals to 0, I less than n, and I plus plus. So int mask equals to 2 to the power I. It means one left shift of I. It is 2 to the power I. Understand? This is done. Then I will I will push the element q dot push of I. First integer is showing the index, so I comma, this will be I comma, the distance will be 0. Initially the distance will be 0, and I will pass the mask, this one. This is done. Then visited, in this visited array, not fat, it is a fat, it means fat. In this visited set, first integer is showing the index, so I'll pass I comma, this one I comma, because it is pair, that's why I'm using this bracket, I comma mask. It is done. So we have done this loop. Now I will use while loop, while not of q dot empty. In this while loop, I will write int value equals to q dot front. We can use it is like a node, so this is a here auto node equals to q dot front. Int value equals to q dot front, so node dot first. Int value equals to node dot first division, and int the second integer is showing the distance, so int distance equals to node dot second dot first, node dot second dot first. And int mask equals to node dot second dot second. In this that we have to pop this element for q dot pop also. This while loop is done. Then I will initialize another loop for auto. can say I equals to I belongs to graph of this one, graph of that particular value, graph of value. In this graph, int new mask equals to, what will be our new mask? So new mask equals to mask of if like a mask or operator, this one, then one less shift of I. It is like if our first mask is 0 0 0 1 and second this one left shift of I is 0 0 0 1 0. It is like 2 1 or 0 0 1 0. Then the OR operator will give me 0 0 1 1. It means we have visited the first and second index. It means 0 and the first index also. If we are starting from 0, that's why 0 and 1 index. So if new mask equals to all, it means we have completed the whole graph. It means visited array equals to 1 1 1. Then what we will do? We have directly returned that distance plus 1. In else if case, in else if condition, if visited dot count of I dot count of I and new mask, then it will be I new mask, then we will directly continue this part. And in else condition, visited dot insert we will directly insert the element in this set. Then visited dot insert of temp new mask, and q dot push off comma comma new mask. You can directly use this one. And 0. So let's run this code. It is giving a OR operator, line number 12. Q dot push off that condition for loop, visited dot insert action. This is done. Then again let's run this code. Line number 24, here should be semicolon. Run this code again. It is working perfect. Let's submit this code. Now it is working perfect. So let's discuss about the time complexity and the space complexity for this solution. So the time complexity will be O of 2 to the power n into n times, because this loop is working from up to n times, and it is from 2 to the power I. It means 2 to the power n into n times. And also the space complexity will be 2 to the power n cross n. So is the complete code for this solution. If you find helpful, then you can subscribe this channel and like and all comment also. You can see this intuition part also, why we are using a BFS, and why we are creating a bit mask approach. So let's done.